Hi kids, in this video we'll solve numericals from Upthrust in Fluids, Archimedes principle and flotation from physics. This is from Concise Physics exercise 5A, class 9. I've already explained the chapter. You can click on the I button and get the link. Number 1. A body of volume 100 centimeter cube weighs 5 kgf in air. It is completely immersed in a liquid of density 1.8 multiplied by 10 to the power 3 kg per meter cube. Find the upthrust due to the liquid and the weight of the body in liquid. What is given to us? Volume of the body is 100 centimeter cube. Weight in air is given as 5 kgf. And density of the liquid in which it is kept is 1.8 multiplied by 10 to the power 3 kg per meter cube. Now, this information is given to us. They are asking the upthrust, FB, denoted by FB. Upthrust we have done is V rho G, where V is the volume of the liquid displaced by the submerged part of the body. Now in this case, the body is completely immersed in water. So volume of the liquid displaced and volume of the body will be same. Converted to meter cube. Now from centimeter to meter, you divide by 100. To cube, so we'll divide by 100 into 100 into 100, isn't it? Meter cube. So this is 100 by 100 into 100 into 100. Now density is 1.8 multiplied by 10 to the power 3 into G. I've kept G because I'll give the answer in kgf. If I want to give the answer in Newton, I'll put the value of G. So that's 3 zeros, 2 zeros from here, 1 zero from here. So 1.8 divided by 10 is 0.18 kgf. That's your upthrust. Done. Number 2. Weight in liquid. Now, weight in liquid. Now, due to upthrust, what happens? The body appears to be lighter. So, and loss in weight is nothing but upthrust, which means weight in liquid will be weight in air minus upthrust, which is F of B. So that's 5 minus 0.18, that's 4.82 kgf. Done. Upthrust is V rho G and weight in liquid is weight in air minus upthrust, the loss in weight. Done. Chalo. Now look at number 2. Look at number 2. A body weighs 450 gram force in air and 310 gram force when completely immersed in water. Find the volume of the body, the loss in weight of the body and the upthrust of the body. These three things. First of all, weight in air is given as 450 gf. Weight in water is given as 310 gf. Okay, they have asked for the volume of the body. Number 2, loss in weight of the body. Done. And number 3, they asked the upthrust on the body. First thing, very easy. Loss in weight of the body is what? This minus this. That's quite logical, isn't it? That's 140 gram force. Done. Loss in weight is 140 gram force and loss in weight is nothing but upthrust, isn't it? That's 140 gram force. Done. Now volume. We know upthrust is equal to V rho G. We've done this. Now this is 140 gram force. We don't know. Rho is 1 because it's water. So we are assuming that the density of water is 1 gram per centimeter cube, and G I'll write as G only because this is gram force. Okay, so volume is what? 140 centimeter cube. So this will be 140 centimeter cube. Done. Loss in weight, you subtract the 2, that is upthrust only, and from upthrust we get the volume. Done. Sure. We'll do number 3. Look at number 3. you're provided with a hollow iron ball A. There's a hollow iron ball A of volume 15 centimeter cube and mass 12 gram, and a solid iron ball B of mass 12 gram. Both are placed on the surface of water contained in a large tub. So you have tub over here and you place both the ball. Okay, where is it? Yeah, both are placed on the surface of the water contained in the large tub. Find upthrust on each ball. Which ball will sink? Give reason for your answer. And density of iron is 8 gram per centimeter cube. Density of iron, both are made of iron, 8 gram per centimeter cube. Look at ball B first. Now, the weight of ball B, will be 12 gram force, because mass is 12 gram. So we don't put the value of G. Actually, weight is mg. This is 12 gram. So 12 into G. So that's 12 gram force. Weight is that. Now, upthrust, FB. Now, upthrust is V rho G, isn't it? Now, volume of this body is, volume is what? Mass by density. So, mass is 12, density is 8. Rho of water is 1 into G, because I'll give this in gram force. So, that's 1.5 gram force. Now, see, the upthrust, when we see that the body is supposed completely immersed in water, the upthrust is equal to, is less than the weight of the body, which means the body will sink. The upthrust over here clearly is less than the weight of the body, weight of B, which means the body will sink. So this body will sink, no doubting that. Upthrust is what? V rho G. Now, this one. So the weight of this body is 12 gram force. Now, let us assume that it is completely immersed in water. Let us assume. Then upthrust, FB dash, when it is immersed in water, completely immersed in water. Now, it is completely immersed in water, then upthrust will be V rho G. V is what? 15, rho is 1, and G as it is. So that's 15 gram force. Now look carefully. Upthrust is greater when the body is completely immersed in water. Then upthrust is greater than the weight of the body, which means the body will not sink. It will float. It won't sink. It will float. With that much part submerged inside water, where the upthrust becomes equal to the weight of the body. This we have studied, which means in this case FB dash will be equal to the weight of the body, which is 12 gram force. When it is floating, you need to write this. So when it is floating, it will float. The upthrust will be 12 gram force, which is equal to the weight of the body. Done. What they've asked? They've asked this only. Find upthrust on each ball. So on A, it will be 12 gram force. On B, it will be 1.5 gram force. And which ball will sink? Of course, ball B. Done. Sure. We'll see number 4. Now look at number 4. Very interesting. A solid of density 5000 kg per meter cube. Density of the solid is given as 5000 kg per meter cube. Okay. Weighs 0.5 kgf in air. So weight in air is 0.5 kgf. It is completely immersed in water of density of water we know 1000 kg per meter cube. Calculate the apparent weight of the solid in water. So weight in water they are asking. Now we know upthrust is weight in air minus weight in water. Done or not? Now upthrust we'll find first. Now upthrust is V rho G. This body is completely immersed in water. They have told. Yeah, completely immersed in water. So FB will be what? Volume. Achhe, the weight in air is given. The density of this body is given. So we'll find the mass. Mass will be what? Since the weight is 0.5, so mass will be 0.5 kg. The weight is 0.5 kgf, isn't it? If you put the value of g, you'll get it in Newton. So mass is this. So volume is what? Density is mass by volume. So volume is mass by density. So volume is mass. Mass is 0.5. Density is 5000 rho, which means density of the liquid. This is density of the liquid. Remember, this was density of the solid. Density of the liquid is 1000. G, I'll keep it like G because I'll get it in kgf. So the 0.1 kgf. Now that's the upthrust. Put it over here. So 0.1 weight in air was what? 0.5 minus x, suppose. So x is what? 0.5 minus 0.1. That's 0.4 kgf, which means weight in water will be 0.4 kgf. Yeah, and that's the answer. Then we got the upthrust, and then this relation we used. Sure, we'll do the next one, number 5. Now look at number 5. Two spheres A and B, each of volume 100 centimeter cube, are placed on water, and density of water they have given as 1 gram per centimeter cube. The sphere A is made of wood. The sphere A is made of wood, and the density of wood is given as 0.3 gram per centimeter cube. And the sphere B is made of iron. This is made of iron, and density of iron they're given as 8.9 gram per centimeter cube. What they've asked. Number A. Find the weight of each sphere and the upthrust on each sphere. First of all, weight. Now, weight of A, which is made up of wood. Weight is what? mg. Mass is what? Volume into density. Density is mass by volume. Density is mass by volume. So mass will be volume into density. What is this volume? 100. And density is 0.3. 0.3 into G. I'm not putting the value of G because I'll get the answer in gram force. So that's 30 gram force. That is the weight of A. Yeah. Weight of B. Now weight of B. Same logic. mg. Now mass is what? Volume into density. That's 100 into 8.9 into G. That's 890 gram force. See, if you put the value of G, you will get it in dyne. Okay? 890 gram force. Now they ask the upthrust on each sphere. Now, look over here. Upthrust on each sphere. Now in this case, for the ball B, where it is completely immersed in water, suppose. So upthrust will be V rho G, where rho is the density of the liquid. So that's 100 into 8.9 into G. Isn't it? V rho G. Okay. V of liquid was 1. So that's 100 gram force. Yes or no? Which means the weight of the body is more than the upthrust. which means the body will sink. It will sink, isn't it? And the upthrust will be 100 gram force. Yeah, on B. This is on B. On A. Upthrust FB dash will be V rho G again. So V is 100, rho is 1 and G is 10. So that's 100 gram force. Now look carefully. Upthrust is more when it is completely immersed in water. You know, when it is completely immersed, then the maximum upthrust occurs on the body. Now, this is 100 GF, the weight is 30 GF, which means the upthrust is more than the weight, which means the body will not sink, it will float, and it will float in such a fashion with a part of it inside water such that the upthrust becomes equal to the weight of the body, which means upthrust while floating will be 30 gram force on A, isn't it? We did a sum like this, okay? Yeah. And they've asked, it's a sphere, A will float, yeah, and this will sink. Done. Which sphere will float? Give a reason. And of course, the density of water is 1 and the density of wood is 0.3. So the density is less, it will float. Clear? Chalo, we'll do number 6. Now look at number 6. What are they told? The mass of a block made of a certain material is 13.5 kg. Okay? And its volume, the volume of the block, is 15 multiplied by 10 to the power minus 3 meter cube. And they have given density of water in which it is kept is 1000 kg per meter cube. What they are asking? Calculate the upthrust on the block if it is held fully immersed in water. Now, when it is held fully immersed in water, upthrust will be V rho G, rho L, rho of the liquid. Now, volume is 15 into 10 to the power minus 3. Rho is 1000, G as it is because we'll give the answer in kgf. So this and this cancels out. So 15 kgf, that is the upthrust when it is completely immersed in the liquid water. Number B. This is A. Will the block float or sink in water when released? Give reason for your answer. Now, weight is mg, that's 13.5 kgf, isn't it? Now, weight is less than the upthrust when it is completely immersed in water. You're holding it with a force. When you remove your hand, what happened? Since the upthrust is more than the weight, it will rise up with certain portion of it inside water. It will float. What is the question? Will the block float or sink? It will sink, of course. It will float. It will float. And what will be the upthrust on block while floating? While floating, just now we did. When it is floating, the upthrust is equal to the weight. So upthrust while floating is equal to the weight, isn't it? That is 13.5 kgf. Yeah. Done? Pretty easy. Now look at number 7. A piece of brass weighs 175 gram force in air. So weight in air is 175 gram force. And 150 gram force when fully immersed in water. 150 gram force. The density of water we know, it's 1 gram per centimeter cube. They've given it. What is the volume of the brass piece and why does the brass piece weigh less in water? First of all, they want the volume of the brass piece. Now, upthrust is equal to loss loss in weight. We know this, isn't it? And upthrust is V rho G, V of the liquid. And loss in weight in this case will be 175 minus 150. So V into 1 into G is equal to 25 gram force. I'm not putting the value of G because this is gram force. So V will be 25 centimeter cube. Done. Simple. Number 2. Why does the brass piece weigh less in water? Of course, due to upthrust. Due to upthrust, it weighs less in water. Done. We'll do number 8. Now look at number 8. A metal cube of H 5 centimeter and density 9 gram per centimeter cube is suspended by a thread so as to completely immersed in a liquid of density 1.2 gram per centimeter cube. Find the tension in the thread. Take G as 10 meter per second square and they've given the answer in Newton. Now what happened with the thread? There is this cube, isn't it? Which is completely immersed in a liquid. Okay, what is given to us? Edge of the cube is given as 5 centimeter. Density is given as, density of the body, is given as 9 gram per centimeter cube, and density of the liquid in which it is kept is given as 1.2 gram per centimeter cube, and G is what? 10 meter per second square. Now, edge of the cube is given. What they've asked for? Tension on the string. Now, when it is completely immersed in water, suppose the tension on the string is T. That will balance the weight of body in the liquid. It will balance that much only. Upthrust is equal to weight in air minus weight in liquid, isn't it? Loss in weight, which means weight in the liquid is weight in air minus upthrust. Am I clear or not? Done? Sure. First, find upthrust. Now, upthrust when it is fully immersed in water is V rho L G. Now, volume, this is 5 centimeter. Edge. So, volume will be what? Volume of a cube is side into side into side, centimeter cube. So, volume is, if I change it to meter cube, because they have given the answer in Newton, so I'll change it to SI unit. So, that's 5 into 5 into 5 divided by 100 3 times, because centimeter to meter, we divide by 100. So, centimeter into centimeter into centimeter cube. Density of the liquid is 1.2 gram per centimeter cube. Now, from gram per centimeter cube, how do you change to kg per meter cube? You multiply by 1000, isn't it? How come? Just look over here. This is gram per centimeter cube. Now, gram changes to kg. So, 1 by 1000. And centimeter changes to meter cube. 1, 2, 3, 4, 5, 6. This is meter cube. So, ultimately what happens? This 1000 goes up. So, we need to multiply by 1000. So, 1 gram per centimeter cube is 1000 kg per meter cube. So, you multiply by 1000. So, that's 1200 kg per meter cube. Am I correct? So, that's 1200 kg per meter cube. And G I have taken as 10. So, 1, 2, 3. 1, 2, 3. Done. So FB is 5, 5 is a 25, 25. We can cancel this also. This is 20 times, 4 times, 2 times, 2 1 time, 6 times, 2, 3. So 1.5 Newton. This is the upthrust acting on it. Yeah, 1.5 I have got. Okay. Now the weight. Let us find the weight in air. Number B. I'm finding weight in air. Weight in air is nothing but mg. Now mass. Density equals to mass by volume. So mass is what? Density into volume. Density of the body is 9 gram per centimeter cube. So this will be 9000 kg per meter cube. So that's weight will be what? Weight in air will be 9000. Okay. Into mass is what? Density into volume. Volume is what? Volume we have got 5 into 5 into 5 by 1, 2, 3, 4, 5, 6 zeros. Into G, that is 10. Done? Now just solve it. 3, 4. Done. So that's 5 1 time, 5 20 times. 5 1 time, 5 4 times. So that's 9 5 is the 45 by 4. 9 5 is the 45 by 4. That's how much? 11.25 Newton. That's the weight in air. So weight in the liquid will be weight in air, that's 11.25 minus 1.5, that's 9.75, isn't it? 9, 10, 11, yeah. 9.75 Newton. That is the weight in air. Weight in the liquid, sorry. That is the weight in the liquid. And that is equal to the tension. So the tension on the string is nothing but 9.75 Newton. Yeah, that's the correct answer. Then step by step, you find the upthrust V rho G. Just be careful with the unit. Then weight in air is mg. M is what? Density into volume. Okay, G is 10. Put the value, get the answer. Then weight in air is, once you get weight in air, find the weight in liquid. That is equal to the tension. Now look at number 9. Now look at number 9. A block of wood is floating on water with its dimension 50 centimeter into 50 centimeter into 50 centimeter, which means volume will be 50 into 50 into 50 centimeter cube. Okay. Calculate the buoyant force acting on the block. Take G as 9.8 Newton per kg. Very easy. Upthrust is what? It is in water. Calculate, yeah, floating in water. Now, upthrust, a buoyant force, is V rho L into G. Volume, what is volume? Centimeter cube. We'll change to meter cube. So 50 into 50 into 50 by 100 into 100 into 100. Rho is 1, we know. Water, density of water in SI unit is 1. G is 9.8. So 1, 2, 3. 1, 2, 3. Okay. Then 5 1 time, 5 2 times. 5 1 time, 5 20 times. 5 1 time, 5 4 times. That's 9.8 by 8. Isn't it? That's how much? 9.8 by 8. 8 1 times 8. 8 2 times 16. 2 0. 8 2 times 16. Then 4 5. 1.225 Newton. That is the buoyant force or the upthrust. Yeah, that's the answer. Very easy. V rho G. Just use this. Now let us see the last one, number 10. Now look at number 10. A body of mass 3.5 kg displaces 1000 centimeter cube of water. So volume of water displaced here is 1000 centimeter cube. of water when fully immersed inside it. When fully immersed inside it. Number 1. Calculate the volume of the body. The volume of the body. Number 2. The upthrust on body and the apparent weight of the body in water. Weight in water. Chalo. First of all, when the body is completely immersed in water, then the volume of the body and the volume of the liquid displaced will be same, which is volume of the body is 1000 centimeter cube. Done. Now, upthrust. Upthrust is V rho L G. Now, V is 1000, G is 1, rho is 1, water, they have told. Density of water in SI unit, CGS unit is 1 gram per centimeter cube. G, we write it like this. So that's 1000 gram force. They've given the answer in kgf. So we know 1000 gram force is 1 kgf. Done. Weight in water. So weight in water is nothing but weight in air minus upthrust, isn't it? Weight in air is what? 3.5 kgf minus 1 kgf. That's 2.5 kgf, which means the weight in water will be 2.5 kgf. Yes, that's the answer. Done. So in this video, keep it till here. In the next video, we'll do the next portion. Till then, take care and be safe. And if you like the video, do subscribe, share.